Let me first start with a quick introduction about 3D bioprinting. I think some of you are already familiar with the concept, but just really, really quickly, 3D bioprinting is very much like a 3D printer where, basically it's a robot that moves in the XYZ direction, and you're able to basically control the robot to extrude materials in a layer by layer fashion to create a 3D object or a 3D model. But in this case, the difference here is that instead of extruding plastic materials, we're actually using bioinks to encapsulate cells, and therefore you will be able to create 3D tissue structures using a bioprinter. And most of these inks are polymer-based. They could be natural polymers or synthetic polymers, and typically people will combine these polymers with different kinds of cells. And using the bioprinter, you would be able to dispense or displace droplets of cells and ink in a layer by layer fashion. And as you can see in this image, you could see that this also uses a biopaper as a support material to stack each layer. And therefore, at the end of the day, after you culture the structure, you will be able to get a 3D tissue. So that's basically the process. And, So just really quickly, one of the main applications of bioprinting is obviously for tissue engineering application. And here's a basic concept of tissue engineering. The idea here is that you want to take samples or cells from a patient and culture that in vitro. And once you're able to get sufficient number of cells, we will be able to then put that in a 3D scaffold material and create a graft that is for replacement. So a great example of that would be like a bone graft, where the patient may have a severe bone injury and loss of bone tissue, and tissue engineering would be an ideal approach to replace this tissue and help the patient regenerate as well. So here are some examples of how bioprinting has been utilized to create different types of tissue constructs. As you can see from these images, there's different shapes and design that you could obviously create into the structure, right? And here, with the aid of a bioprinter, you're able to obviously create pretty intricate and sophisticated structures of any shape and size, and also integrate cells into these components. Therefore, many applications that are being used and being pursued today are bone repair, tissue replacement, blood vessels, and of course, ultimately, organ printing. So today, we will use a material called pluronic, which is basically a synthetic material made out of these two polymers, PEO and PPO. And pluronic is often thought of as a sacrificial material because it has a very unique thermoreversible property in that, at low temperatures, it actually melts away and it's in a liquid state. But as you increase the temperature, it actually is in a solid or semi-gel-like state. So it becomes very printable. And today we will be using this material to print the different scaffolds that we'll be creating with you today. And again, this is also a material that is non-toxic and biocompatible. So it's been already used in the materials community for various tissue engineering applications. So quickly to go through the steps in terms of taking you from design to print. The first step is to design a scaffold, and what we'll do today is basically to design two simple scaffolds, and then basically kind of walk you through the different software that is used for designing these scaffolds. After you design a scaffold, you would then slice the model. So the slicer program, there's numerous slicer programs out there in the market. But what really comes down to the use of these slicing programs is basically they're taking a 3D model, which is often in the STL format, and translating a 3D virtual model into language that a 3D printer or bioprinter can understand. And that's really the function of the slicing program, right? So they're converting a 3D model into G code, which is the programming language that controls the printer, and then allowing you to then take that file and load it onto a bioprinter or a 3D printer and create that 3D object. So today we'll walk you through that process, and you'll be able to see how that process works. Okay, and the two programs that we'll be using today are Tinkercad and Slicer. So we want to start with something really basic. Tinkercad, for those of you, or for most of us who may not have any background in CAD design, this is probably the great place to start. Tinkercad is very easy to use. It's free. It's web-based software that is provided by Autodesk. So for those of you who haven't used this before, I think you'll find that the tools are very intuitive. So please go ahead and create an account if you haven't already done so. Again, you can create a free account using Tinkercad. And then the next software that we'll be using, which, as I mentioned, a slicing program, is called Slicer. And this is also a free open source software that will allow you to convert a model to a programming language for the printer. So with that, I will first introduce the first design scaffold that we'll be doing. And the first scaffold we'll be designing is basically a cube, right? So these are basic shapes, and it could be a cube, it could be a cylinder, but here we'll start with a cube. And what you will be able to do here is that you could also design different infill patterns using Slicer program, which Oliver will show you how to do that. And basically you can modify, different parameters of the infill pattern inside this cube, all right? And we'll also talk about size adjustments. How do you, define or control the size of the cube that you want to create? So with that, I will now transfer my slides over to Oliver. So let me, give me a minute. And in the meantime, you guys can also, log into Tinkercad, and you can start following his tutorial. Wait. I have to find you, Oliver. There you are. Okay. Right, so you're host.
Okay. Everyone, so myself, Oliver, will be walking you guys through making some simple scaffold designs. So I'm already on the Tinkercad website, and what I'll do is just choose Create New Design, just start a new one. So over here on the right, you can see that they already have a basic shape selector. So we have a cube, cylinder, and a bunch of other ones that you can choose from. And these, you can really use these as building blocks to make a more complex model. But for now, we're just going to start with the cube or the box. And I'll just drag that over onto the work plane. And really the only parameters that we're going to be concerned with here are the size. So I have these anchor points that I can click and hold to resize the model. Or I can just select these size boxes, and I can just type in any value that I want. And then I'll also adjust my height for this cube to be around 6 millimeters. And once I'm happy with that, I'll go to export. And then I'll choose download for 3D printing as an STL file. And so that file's downloaded. And now I'll switch over to Slicer. And the first thing I want to do is to go to File and load the config file. And this is just a file that contains all the pre-saved settings for the material that we're printing with. So in this case, I'm going to choose the Pluronic 14 gauge config file. And just to double check, the print settings over here in this pane on the right should confirm that you have your setting And now I can go ahead and click add, and I'll choose the object that I just made from Tinkercad. And so here in the preview pane, you can see that I have my cube object. And if I go to the preview pane, you can see how the slicer program actually slices the model into layers.
Oliver, you're still on the, no, you're not on slicer.
I'm not.
No, you're not. We're still seeing Tinkercad. You need to exit the screen and share the slicer screen.
Oh, okay.
Sorry, everyone. We'll go back to slicer again. Yeah, let's go back again. Yeah.
Can you see it now?
Yes.
Okay.
So maybe
start back. Let me start all over again. So the first step in Slicer you want to do is to go to File and Load Config. And here I'll choose the Floronic 14 gauge config file, which just has all the safe settings I want. And then you'll see over here that it confirms that I have the Floronic file loaded. So now I can go to Add to choose the model that I want. So here I have the cube I designed earlier in Tinkercad. And then the preview pane is how you can see this model has 4 layers, and then I have a sort of honeycomb style infill that's hexagonal. And in order to change these settings, I can go to Print Settings. So here is layers and perimeters. So here I can choose how tall each layer is, how many perimeters I want. So in this case, I just have 1, which is this yellow outer perimeter. And I can also change the infill. So here is the honeycomb setting with a density of 40%. So I can drop this down to 5% per se, and you can see how the density has decreased a lot. Or I can also change this to a rectilinear fill, and that's just a more traditional sort of crisscross pattern. And I can also change the angle at which this comes in by changing the fill angle. So if I change this to 0, you can see how it's more aligned with the perimeters now. But today we're just going to go ahead and print with a 40% honeycomb infill. And so once I'm happy with that, I'll go to export G-code, and I'll call this Scaffold 1 and save. And now I'm ready to print. So for that, I'll switch over to Pronterface, which is the program that we use to control a 3D printer.
Close this one.
Okay. So really quickly, this is the manual controls for controlling the printer in the X, Y, and Z directions. So if I click +Y, you can see how the oh.
It's only showing.
Okay. Should I just transfer the view back to you? Because I'm about to load.
It's okay. I think you load. Maybe you just, yeah.
Okay.
Yeah, you can load the scaffold, and then we'll show you.
So if I load the G-code file that I just made, you can see in this preview pane how the little preview of the scaffold shows up. And now I'm going to just go ahead and load the syringe into the printer for printing.
So I guess you can.
And I can switch the view back to Maya so she can.
I can show you guys the actual 3D printer. Yep. I will, let me see. Wait, I think I need to not share the screen. It's not showing me. It's still you.
Oh, I mean the host.
Okay, there we go. So now that I'm the host, it should show my video, I think. Is it not showing? Do you see my video?
Yeah.
Yeah? Okay, great. Cool. Okay, so we're just loading a syringe now onto the printer. And as I mentioned earlier, we're using a material called Floronic. So what Oliver is doing now, he's just sort of priming the syringe so that there's actually material coming out of the needle tip before we start printing. And then he's also going to quickly calibrate the Z0 position. So the Z0 basically defines where the model will start printing. So you want to make sure that it's on the right Z height and the right Z level. So it might be a bit hard to see, but we'll show you guys the final scaffold once it's done. If you have any questions, feel free to type in the chat box. We'll probably take a short Q&A right after the print, and then we'll follow to the second model. Okay, so you can see, so you can see the scaffold print that we just designed, and as you can see, this material pluronic it's a very printable material. So it's definitely one of the very commonly used biomaterial in the tissue engineering community. So any questions so far? Maybe should we unmute everyone for Q&A? So I'm going to unmute all of you, and if you have any questions, we'll maybe have 5 minutes of Q&A, and then we'll move on to the next scaffold design. Anybody have questions?
They unmuted themselves again.
No questions? Okay. We could always come back later if you have questions. Feel free to just type it in. So we'll continue to the next session, and I will now show you the second kind of scaffold design that we will work on. It's also a very simple one, but if you want to follow us with your software opened as well, that will be a good opportunity for you to do that. So let me share my slides again. And so earlier we did this, right, where we basically tried different infill patterns and size adjustments, right? So sometimes if you realize that, something is not right or the size is not right, you can still go back to, either Tinkercad to resize the whole shape, or you could also go back to Slicer to make adjustments on the size. So the second scaffold we're going to design today is a very simple cylindrical scaffold. And here, we'll talk a little bit more about how you could adjust the perimeter. And in this case, because we'll basically just build a cylinder with no infill inside, basically it's a zero infill. And, here you can again adjust the height, the distance, and in this example, we're still using the 14 gauge needle. So like each one of you, we've already given you the file for pluronic 14 gauge. So we'll just use the same one. But technically you could obviously use different needle sizes to get thinner perimeters. And the settings for the thinner needle size will be different. But that's something we will discuss in future webinars in terms of adjusting needle sizes and different types of materials. So this will be the second kind of scaffold that we will be printing shortly. So I will now turn my screen to Oliver, and he will show you the software. So I will make Oliver the host.
Okay, so once again, I'm going to go back to Tinkercad and create a new design. And for the cylinder shape, I'll just use this preset cylinder. And then here's where you can adjust the size. So I can hold down the shift key and drag this anchor point to make the whole cylinder bigger or smaller. And then I can adjust the Z height by dragging up and down. In this case, we're just gonna keep it relatively short. And once I'm happy with that, once again, I'll click export as an STL file. And now I'll go back to Slicer. So first I'll delete the old box that I had, and I'll add the cylinder that I just made. And you can see how here right now, I still have that honeycomb infill from before. So the first thing I want to do is go to the print settings, and under infill, I'll just change the density to 0. And so now I'm just left with a series of rings stacked on top of each other to make a hollow cylinder. And some other things I can do are to add a skirt. So if I change this loop value to 1, what this does is to add an outer ring to it that the printer will print first. And that just kind of helps with the print consistency. And if I want to adjust the size of my cylinder, again, I can use this scale function in Slicer to make it bigger. And I can also use this cut setting if I want to change the Z height as well. So once I'm happy with my cylinder, I'll export the G code. And then the same thing, I'll load that file into Pronterface and print it on the printer. All right. And one last thing I can also do is to change the number of perimeter shells in order to make the cylinder thicker. So in this case, I have 6 perimeters, and you can see that now I have really thick walls and only a very small channel in the middle. Or I can change this to 3, and you can see how that affects the size. And today we'll just be printing with 1 perimeter.
So now that Oliver has the design, he's going to, again, load the model onto Pronterface. So here you should see the screen of the printer. Okay, so now that it's done, we can actually kind of show you the scaffold. So you can see there's a number of layers. How many layers was this, Oliver? 8, maybe? 6 or 8 layers. Yeah, about 9 layers. So you can see there's about 9 layers of prints on this one. And this is a good like 2 centimeters of a scaffold height. And as you can see, it's a very kind of stackable material as well. So it can really hold its structure pretty well. So yeah, so this is Pluronic biomaterial. And that's it for us in terms of the scaffold design today. And let me just go back to these slides real quick. If you have any questions, this will be a good time to ask and type in your questions. Let me see. And share screen. So before you guys go, just wanted to share 2 more things, I guess. So we will have more workshops coming up, and the next one that we will do, we'll talk in more detail about Slicer specifically, because really, you know, when you get into trying to print your own biomaterial with different kinds of viscosity, this is where you really need to learn about Slicer, because that's where we actually tune and make the adjustments to print with the material that you want. So obviously our Slicer settings have been tuned for our bioprinter, and you know, different bioprinters out there in the market will have their own quote unquote Slicer settings. And that's where, you know, that's where the kind of R&D and iterations and engineering really goes into it. And in the next scaffold design webinar, we plan to talk a little bit more about these tools in Slicer. And also, if let's say you have different needle tips sizes that you want to print with, we will also talk about what kind of adjustments you will need to make on the Slicer settings in order to do that. The other thing I want to mention is that we are going to host a free bioprinting workshop at the 3D Heals conference. I'm not sure how many of you are aware of this conference, but this will be held in San Francisco on the 20th and the 21st of April. So 20th of April is going to be the workshop. It's going to be a all-day workshop with many different types of workshop. If you haven't yet visited their website, please go into 3D Heals 2018 to look at their website. And then the other thing is, and then we also plan to have other more sophisticated tools like SolidWorks for advanced scaffold design in the May. So I see there's a question perhaps from Steffi. How can we superimpose 2 images in Tinkercad and have different infill patterns for both on Slicer? You can? Okay, maybe Oliver can address that.
Oh, should I share my screen?
Yeah, please. Let me stop share and let's go to, thank you, Steffi, for the question. Oh, sorry, I'm gonna make you the host. So Oliver will show you some of these tricks. Are you the host? Yeah.
Okay. So in Slicer, you can actually add multiple objects. So in the plater, I'll just add
2 objects. Yeah.
The cube, and I'll also add my cylinder. And if I double click on this object, I can apply some modifier settings. So if I just click this plus sign and then I go down to infill and fill pattern, I can change this to be a different pattern. Oops. And then I can do the same thing. Oops. And I can change this to be rectilinear instead. So now in the preview, I need to change this density. So now you can see how I have a rectilinear infill on the cube, but a honeycomb pattern in the cylinder.
Awesome, that's great, yay. So very cool, very cool. So I hope that addresses your questions, Steffi. Any other questions from anybody else? No, that's it. Okay, great. So thank you again, everyone for joining us. I will send out emails with the link to this recorded video so you can watch back. And if you want to follow the tutorial again, you can always view and take your time to kind of follow that. I will also probably send out a quick survey just to get your inputs and feedback as far as improving this webinar. So please feel free to help us by filling in the survey and give us your suggestions and your inputs. Thank you very much, and I hope that you have a wonderful day ahead. Thank you, everyone. Bye.